Hi everyone. In today's challenge, we are going to solve this problem. The problem name is count all possible routes, and the problem number is 1575. Alright, guys. So as usual, first of all, we are going to clearly understand this problem statement. After that, we are going to move to the logic part. We are going to see how we can solve this problem. What is the logic to solve this problem? And after that, we are going to move to the implementation part. And in the implementation part, we are going to implement our logic in C++, Java, Python, and JavaScript programming language. Fine, guys. Now let's see what this problem says. Right. The problem says you are given an array of distinct positive integers locations where location of I is represent the position of city I. So basically guys, the first line simple say that we are given first of all a location array, right? Locations array where every elements is going to be always unique, distinct, and then it is also going to represent nothing but we can say position of any city, right? Position of city I. That means let's say here is 2, here is 4, here is 5, here is 3. So this 2 is nothing but the position of city 0. This 4 is nothing but position of city 1 because it is 0 index, 1 index, 2 index, 3 index, right? So 5 is nothing but position of city 2 and 3 is nothing but position of city 3 itself, right? I hope it makes sense. Now you are also given an integer start, finish and fuel representing the starting city, ending city and the initial amount of fuel you have respectively. So now we are given three more integer. The first one is start, which tells us that here we are going to start from which city we are going to start, from which city we are going to start, and then finish. What is our target? Which city is our target? Which city target? And the last one is nothing but fuel, right? How much amount of fuel we have in our car or any you can say vehicle, right? So that is the total fuel we have. We can't use this more than this fuel, right? At each step, if you are at city I, you can pick any city j such that j is not equal to I and j should be in between of 0 and the length of locations, right? And move to the city j. So guys, simple say at each step, means at one step, what you can do, you can, if you are city at I, means if you are any city, you can move to any other city. You could not move to the same city, you can move to any other city. And after that it says that that city should also belong to in location arrays. Like here you can see we have city 0 to 4, right? We have here 4 city, right? So if I'm at 1, so I can move to 0, 2 and 3, right? I can move any city but not at 1 itself, right? Simple things, right? Moving from city I to city j reduce the amount of fuel you have by location of I minus location of j, the modulus of this, or we can say absolute value, right? So simple thing guys, if I am moving from 1 to 3, so you can see on 1 I am having 4, right? And on 3 we are having a 3. So if you will subtract 3 minus 4 or 4 minus 3 and take the absolute value, so you will get 1 only, right? So the cost or the fuel we are going to spend is only one, we can say one amount fuel we are going to spend from 1 to 3, right? I hope it makes sense. So total fuel is going to take by is nothing but absolute value of 4 minus 3, right? Or we can say 3 minus 4. Please notice that model of x denotes the absolute value of x, right? So guys, here we are trying to understand the problem, right? Don't worry about the logic part. We'll move to the logic part as well. But first of all, let's see what this problem says, each line by line, because it is a hard level problem. If you miss any single line, maybe you will not understand the logic part as well, right? Now notice that fuel cannot become negative at any point in the time and that you allowed visit any cities more than the ones including start and finish time. Simple guys, if your fuel become negative, means you don't have fuel right now, so you can't move any more city, right? You will end up on that city only, right? Now return all the count of all the possible routes from start to finish. Since the answer may be too large, return it modulus 10 raised to 9 plus 7. Simple now guys, they have told us that we have to reach from, we are given start, right? And we are also given end point. So we have to start from the start city and we have to reach to the finish city, and we have to tell us that how many possible routes exist to reach from start 1 to start 3, so that our fuel should not be more than this given fuel, right? Fine. So now let's understand the example 1 and see how they are getting answer 4, right? So you can have a better understanding with this, right? So guys, we have initial locations this 2 3 4 6 2 3 6 4 8 2 3 6 8 4, right? So we have this initial array, means this is locations, and city is nothing but 0 1 2 3 4. This is the city respectively. Now we are starting from first city. Start is going to be nothing but fun, right? And finish is 3 and 5, fuel is 5, right? So I'm at standing at here, right? I hope it makes sense. You can see this my cursor, right? Now what I'm going to do, I'm going to say from 3 I want to move to the finish 3, means third city, right? Means here. So if I directly move there from 3 to from this 1 to 3, so you can see the amount I the fuel which is going to consume is nothing but absolute of 8 minus 3, right? What we can do like this, 8 minus 3 is 5, right? So we can say 5 amount of fuel is going to consume, and total fuel we can take 5 only, right? We can take this much. So you can say right, it is cool. So we can directly go from 1 to 3, and you can see first option is this only, right? Now let's move to the second option. Let's say I don't want to go directly, I want to take any other route. So let's say first I went to 3 to from one city to second city. So we're going to take a fuel 6 minus 3 absolute value, which is nothing but 3 only. And after that 2 to 3, so which is going to take 8 minus 6, which is nothing but 2 only. So total fuel which we have taken is 2 plus 3 is nothing but 5 only, right? So this is also cool, we can take this much fuel. So we can say there is one more possible route, 1 to 2 and 2 to 3, right? Now I don't want to take this one as well. Let's say I directly go 1 to 4, right? So which is going to take a fuel nothing but 4 minus 3. 4 minus 3 is nothing but equal to 1. After that from 4 I move to nothing but 3, right? So which is going to take 4 minus 8, which is nothing but we can say minus 4, and absolute value is going to be nothing but 4 only, right? So total fuel they are taken nothing but 1 plus 4 is 5 only, right? So this path is also valid. So we can say this route also I can take. You can see guys, we have taken 1 to 3, 1 2 to 3 and 1 4 to 3, right? 2 means like this one 2, right? So we can say directly 1 3 1 2 3 and 1 4 3, right? After that let's say I am taking from 1 to 4, then 4 2 we are going to 2 and 2 2 we are going to 3, right? Still you can see guys the path is valid, because 1 to 4 is going to take nothing but from 1 to 4 we are taking nothing but total fee is 1, and then 4 to 6 is total fee 2, 6 to 8 is also 2, so 2 plus 2 plus 1 is nothing but 5 only, right? So this is also valid. So here all the possible routes we have seen are taking exactly 5, right? It may be the case some of the fuels can take less than 5, that will also be valid, but here we could not find that case. But yeah, if any of the routes which is taking less than or equal to fuel given fuel, that is route is going to be nothing but valid, right? We have to count that particular route. So you can see guys, we have 4 valid routes, so we are going to return nothing but answer 4 only, right? Now let's move to the next example. Here you can see we have 4 3 and 1, start is 1, finish is 0, fuel is 0. So let's write quickly this as well, 4 3 and 1 guys, and here 0, here 1, here 3. Let's me take a different color, right? And we are taking so much time on these examples because we know that this is going to build our base, right? So 0 1 and 2, right? So what we are going to do, we are going to start from 1 index, so it means this city, first city. Now from 1 what I want to reset 0, right? So what I can do, I can say from 1 we can go to 0. Directly we can go to 0. This is going to take only fuel one amount, right? And we have a limit of 6. We can take at max 6 fuel, so it's going to take only one amount, but still we are going to consider it because it is less than our fuel. So when we, this is path 1 to 0, right? Now from 1 we don't want to go 0, we want to go to 2, right? So we took 2 path, and that is going to take 3 minus 1 2 absolute path, 2 fuel, right? From 2 now I want to go to 1, which is going to take nothing but 5 more. No, from 2 I want to go to 0 part, and here we have, right, fine. So guys, you can see from 2 what I'm going to do, I'm going to take a 0 part, right? So how much fuel this is going to take? This is going to take 3 only, right? Because 4 minus 1 is 3, right? So we can say nothing total fuel we have taken nothing but 5 only, right? So if it is 5, so it is also less than our 6 fuel, which is given 6. So we are going to say this path is also valid, right? Now let's move to the next scenario. I'm going to from 1 to 2, fine, but from 1 to 2 again I want to come to the 1, right? Which is going to take nothing but we can say 1 to 2 and 2 to 1 is nothing but 4, right? Total amount 4 is going to take, right? 1 to 2 is 2 and 2 to 1 also 2, right? Then from 1 I want to come, we can say nothing but 0, right? So it is also going to take one amount, so which going to say total 5. Now from 0 I want to go to 1, so this is also going to take one amount, which is going to be nothing but equal to 6 now. So think guys, this is also valid, right? It should not be valid, right? Let's check this again. So from 1 I went to 2, which is going to take amount 2. From 2 I went to 1, which is going to take amount again 2, which is going to be the 4. From 4 I want to go to 0, right? Which is going to take amount 1, right? So total amount we have taken 5 only, right? Okay, so this is also valid. See guys, what I want to tell you in this example is that we can repeat that particular city again and again, right? Here is the scenario. You can see we have visited 1 again. You can see 2 cursors are coming. One time I'm going to 2, then again coming back to 1, then coming back to 0, right? So that means I can repeat a city again. So that is the main valid point in this particular example. So we can repeat the city again, and also we can take that particular routes or path which have a less fuel, which is consuming a fuel less than our total fuel as well, right? So by doing this, you will get a 5 example, 5 paths. So you are going to return this 5 as an output, right? So that was the simple basically I want to tell you in this example. So we have seen the 2 example. Now let's move to the last example. Here we have seen 5 to 1, like start is 0, finish to 2. So fuel is nothing but 3. So you are at this is 0 index, this is 1 index, this is second index. You are starting from 0, and no matter where you want to go, right? You want to go to this second index, right? No matter which path you are going to take, that will going to take a more than our given fuel, right? So we are going to return nothing but answer 0 only, right? I hope it makes sense. So guys, we have seen the examples, we have understood the problem statement. And if you have any kind of doubt still in this particular problem statement part, you can write in the comment section. I'm always there to help you, right? Now guys, let's move to the logic part finally. The problem statement was really bigger, right? It took, I think, almost 5 to 6 minutes. I can't see the time, but yeah, it may have taken more than 5 minutes, right? Now let's write a logic part. Now guys, think about this logic, how you can use it, what logic you think it's going to be valid here, right? So we have this particular thing, right? We have this example, so let's remove all these things and let's take a logic with the first example, right? So think about just a scenario of recursion or DP, anything else, right? Whatever you know, think about something. So what I'm going to take this first example, right? Or 2 3 6 8 4. I'm not going to do all the things, but yeah, I will give you a quick glimpse of logic, right? What is gonna we are going to do here, right? So think about this. What we can do, guys? We are at zero index, we are at one index, we are at second, three and four. These are nothing but city, right? Now think about this. As we know that, guys, from we are currently at one index, we can take any possible step, right? So this is going to be just a simple recursion. It's not a hard level problem, it's just a, I would say, medium level problem, right? So what I'm going to do, I'm going to start from one. So think about a recursion tree here. Currently I'm at which index? I'm at one index, and I have taken a fuel nothing but zero. You can see we are starting from one, so we have not taken any single fuel right now, right? Now the scenario began. So here from one, where I can go, let me make a this tree so that you can get a better understanding. From one, I can go to, where is my cursor? I can go to zero. If I go to zero, how much fuel we are going to take? We are going to take nothing but 3 minus 2 is, and take an absolute value that is nothing but 1 only, right? So we are going to take nothing but 1 fuel. If I go to 1, and here the problem statement comes, right? If you have focus, if you have seen my problem statement and that part, so here we have discussed that we can't move where I is equal to j, right? That means we can't take I is equal to j, means we can't move to the same city again and again. Here you can see again, if you haven't focused over there, j should not be equal to I, right? So we can't move to the one, but we can move to two. So for two city, we are going to take a few nothing but 6 minus 3 is 3. Now we can move to three. Three city, we are going to take 8 minus 3 is nothing but 5. We can move to four. Four is going to take 4 minus 3 is 1, right? So we can move to this much city, right? I hope it makes sense. Now what we are going to do, once we have done this, we are going to again move again. So here, first of all, we are going to check this city. Is it the finished city? Finished city was 3. No. Is this is the finished city? No. Is this is the finished city? Yes, 3 is the finished city. So what we are going to do? Okay. So sorry guys, I don't think my face will be visible to you, but yeah, cool. Light has been gone, right? I don't have inverter. So for 3 city, what I'm going to do? So mostly you will be focusing on my screen part, right? So there will be no problem for your side, right? So what I'm going to do, I can say for 3 city, I reach to 3. So what I'm going to do, I'm going to say increment this one, right? So here I'm going to say increment this by 1 because we have reached to one position, right? But 4, it is also not a finished city. Now what we're going to do again the recursion part with this one. 0, 2, 3, and 4, right? So what I'm going to do, I'm going to say for 0, again you have four some possibilities, right? So let me, so this particular part for 0, what we are going to do, we're going to say you have again possibilities, 4 possibilities. From 0 you can move to 1, right? We can repeat the part, right? We can again move to the 1. For if you're moving to the 1, so you guys can see we have this array, right? So if we are moving from 0 to 1, let me go to a, okay, see here guys, if we want to move, go to 1 from 0, this is 0, we want to go to 1, then we are going to take a one more fuel. So we are going to say 1 plus 1 is going to be nothing but 2 only, right? If we go to 2, that 6 minus 2 is 4. So we are going to add 4 in this. So we can say 4, 4 plus 1 is 5, right? 6 minus 2 is 4, 4 and 1 we have already taken fuel, 4 plus 1 is nothing but 5. And if we go to 3, then 3 is nothing but we can say 8, right? So 8 minus 2 is nothing but 6, 6 plus 1 is 7. So 3 is 7. And if we go to 4, so 4 minus 2 is 2 and 2 is plus 1 is nothing but 3, right? So from 0, do we reach to any finicity? Yes, we reach to one finicity, this 3, but it's taking a fuel 7. So we are going to say directly no, 0, right? If any of the case is taking a more than our given fuel, so we are going to stop there, that only the recursion part. Here you can see it is 3, which is less than our given fuel, so we can continue this one. This is 5, so it is equal to this, right? So we still can continue this part, still this part, but here you can see this is greater than 5. So we are going to return nothing but 0 here. We are not going to export this particular part. So we are going to keep doing this particular things, and you will see once you have done these things, so you will definitely will get some case where you will see that all the fuels consumed fuel is greater than fuel. So we'll keep returning there 0 0. So here I'm going to return nothing but 0 only. Here let's say I have written 0. Here again let's say I have written 0, I have written 0. So total you're going to return 0. Let's say it written same thing 2. It's written 1. It's also written 1. So we are going to get nothing but we can say total 2 plus 1 is 4, right? 4. But it's not the case in this scenario. I'm just taking example here, right? I'm just making our scenario. So this is how our recursion going to work. I hope it makes sense. What we are going to do, we are going to say nothing but start from traversing from start and total our total fuel consuming, and move to all other cities except the current city. We can't move to the same city again. So keep moving, and wherever you are getting a final city as this particular start index. So here we can see we got 3, which is nothing but our finish. So keep add 1 into this, and but still explore this particular part as well, because we can visit a city multiple times, right? So we still explore this particular part, but we will add 1 into extra because we have already encountered one route, right? But if we are not getting, then keep exploring. And what we when we got our fuel, total fuel is greater than our given fuel, then we are going to return 0 part. I hope it makes sense, right? So this is the simple logic we are going to use. So this is nothing but recursion, but we are going to make a dynamic programming by memorize it. So we'll memorize it on the basis of this only, start and fuel. So let's see how we can do with our 4 programming language. The first one is nothing but, the first one is Python, then we'll move to C++, then Java, then JavaScript, right? So today I introduced new language JavaScript just because found so many comments on that particular my videos that make a video on JavaScript as well, right? So first of all, I'm with the Python, so I'm going to create a one function define soul, and here in this function I'm going to take start, not start, I will say index, and then total fuel, right? And here in this function, what I'm going to say, let's say first of all, if our total fuel, let me say if okay, I can do like this. If total fuel is greater than a fuel, then we are going to return nothing but 0, right? But if our index is equal to finish, then you can say not return, you can say increment answer by 1, right? And answer is going to be nothing but equal to 0, right? Fine. Once this is done, what I'm going to do, I'm going to say if index is equal to finish, so return do answer plus 1. We have found one path, but explode is still this one also. So we can say for I in range of n, and here we can say n is nothing but, if we haven't know n, so let's say n is nothing but length of our locations, right? Now for I in range of n, what I'm going to do, I'm going to say it's first of all, if it is equal to the same, if I is equal to the index, then we don't want to explore it again, right? So we can say continue. But if it is not the case, so explore it, right? So answer plus equal to sol, and you can say index is going to be nothing but I, then you can say total fuel is going to be nothing but add this fuel, right? So plus equal to absolute of location of I minus location of index. So we are adding that particular fuel, remember, right? So what we are doing, we are adding that particular part, that particular fuel, the fuel which took amount from current city to a target city, right? So we have added that fuel in our total fuel. Then after that we are gonna continue this, right? So after that we are going to return nothing but our answer. I hope it makes sense. But think about this, guys. If I call this function sol and with the 0 index, not 0, start index, and here if I say total fee is initially 0, so if I run this code, it will pass. I think the sample test case definitely it will gonna pass. I haven't written anything, so let me return something, right? Okay, now let's run this code. I hope it will pass the examples, but yeah, it will give a TLE if I run. You can see, guys, if you can see if we have 3 test cases and all the test cases it has passed, but definitely if I try to submit this code, it will give a TLE, right? Why? Because we haven't memorized it, and it will gonna take all the possibilities. So if let's say the length is n, so n is to power n, right? So what we are gonna do, we are gonna say nothing, but we are gonna say let's memorize it, right? So we are gonna make a dictionary. It is gonna be by default empty dictionary whenever first time this function call, and we'll keep dictionary in our this function. And here we are gonna check it first of all. If our this index comma fuel t fuel is in our dictionary, if it is in our dictionary, so what are you going to do, you're going to say return d of index, return the value, right? We don't want to explore it again if we have already explored it, right? And before returning answer, we can say dictionary of idx, and t fuel is going to be nothing but equal to answer, right? And after that you can return answer. So now if I try to run the first of all example test cases, so that we haven't done mess up our code. So yeah, we have messed up our code because we are using a dp and we have defined a d, right? So let's make a dp only, because TP make more sense, right? What is D? We don't know. Fine. And one more place we have done, I think so. Now let's run this code. And I hope, guys, it should pass at least the example test case. First of all, we don't want to see any more error. So you guys can see that all the test case passed, right? Fine. Now let's say to submit this code. I hope it will also submit this one as well. And I hope, guys, you can see this. No, it has given a wrong answer. Let's see what is the happen over here. Alright, so wrong answer just because of this, right? Now think about yourself, right? So this is, I just got what is the wrong answer, right? Just tell me if you able to get it, just let me know in the comments, because this is a very important part if you haven't focused on the problem understanding part, right? So I have to clearly tell you this particular line. Since the answer may be too large, later need modulus 10 raised to the 9 plus 7. So we can say modulus of 10 raised to the 9. So we can say like this, 10 raised to the 9 plus 7. Now if I run, it will gonna, okay, first of all, let's see, submit this code, right? So it will gonna submit this code as well. Why it's taking too much time? Here we go, guys, right? So you can see, guys, it's successfully submitted with Python. I hope it makes sense, right? So yeah, we got a two more error in this Python, but yeah, still we could able to submit this. Now let's move to the next programming language, which is nothing but C++. And I'm doing a bit fast because there's no light and it's a lot of heat in my room. So what I'm going to do, I'm going to say int, not int. Here we can say, first of all, let's define a mode and map, right? So we can say map, pair, int, and here we can say integer, and this is nothing but dp, right? So we have defined our dictionary, or we can say map. Now once this is done, we are going to also define a mode, which is going to be nothing but 10, 1e9 plus 7. This is a C++ benefit. After that, we are going to define int sol, and here we can say, first of all, take a start. We are going to say this is nothing but index only, right? And total fuel which is taken. Then we are going to take a fuel which is given a fuel which we should not be exceed, right? And after that, we are going to take locations. So we can say vector int modulus locations. Let me add a locations. Then we are going to take an n, right? I hope we have taken all the necessaries, right? If we haven't taken anything, we are going to see it, right? So not seeing, we have already figured out that is nothing but finish only, right? So we have to say finish. Now guys, once this is done, what we are going to do, we are going to say, first of all, check it if this dictionary dp to find this idx and fuel total fuel is not equal to dp dot n. That means it is already present, right? So we can say directly given return dp of index comma total fuel. Fine. But if it is not the case, so first of all, check it if total fuel is greater than our fuel. If it is the case, so return directly 0, right? After that, once this is also done, we are going to do one more part, that is nothing but we are going to say if our finish is equal to our idx. That means we have found one valid path, so we are going to say answer plus equal to 1, right? So here answer we haven't defined, so let's define answer as well, right? So answer is initially going to be nothing but equal to 0, right? So we have to say entire type. Once also this is done, so what we are going to do, we are going to say towers over each other possibilities as well, right? So for towers on all the, we can say, cities. So for int I is equal to 0, I less than n, I plus plus, here we are going to say if I is equal to this current index. So let me write here I is equal to index. So we are going to say nothing but continue, right? We don't want to take same city again, right? After that, we are going to say dp, no dp answer is equal to answer plus, and here we can say call this function solve again. Here index is going to be I, fuel, total fuel is going to add, right? They're going to add total fuel, which is going to be nothing but absolute of locations dot I minus location of I tx, right? If you're not getting this part, just let me know in the comment, because here what we are doing and nothing but location of I minus location of idx is going to tell us total fuel we have consumed to reach from idx to ict, right? After that, once we are done this thing, we are going to pass finish. Then we are going to pass fuel. Then we are going to pass locations. Then we are going to pass n, right? Once this is also done, we are going to say pull, and after that we are we are going to come out from this loop. We are going to return nothing but answer, right? Before that, we are going to set in our dp as well. So dp of idx comma total fuel is going to be nothing but, we have to use two curly braces. How is going to be nothing but equal to our answer, right? So equal to answer, right? Now we are going to call this function in this side, this main loop, main function. We are going to say call this solve function, return solve, and here let me write solve, right? Here we are going to pass index as a start, and total fuel is initially 0, finish is going to be remain same, fuel is also going to remain same, and then location is also going to remain same, and n is going to be nothing but location of size, right? So total seed. Now let's run this code, but it will give an error, right? Definitely not error, but a wrong answer. Why? Because we haven't used a modulus operator. So we are going to use a modulus operator. We are going to give a mod because it could be more than 10 is for 9. So modulus of mod. Now let's run this code and see whether it's working fine or not. And I hope guys it should work, right? We don't want to see anything. Yeah, semicolon is there. Why, I don't know, I could not able to pass a single programming language in a first go. I always get an error, and that also too basic. Again, one more error, if finish is equal to idx. So I have done something wrong, use of undeclared variable finish. One more type of error. Great. Let's see, any more error do we have? Somewhere else we have used a finish. Let's check it. Undefined variable didn't mean mode, so we haven't defined mode. What happening? I don't know. Let's run this code now, and I hope guys it should work now. Guys, location dot size finish, again a finish. What's a miracle, guy? I don't want to see any more error now. And here we go, guys, right? So we have passed all the test case. Finally, let's try to submit this code, right? Hopefully don't want to see any error in the submissions. It should pass. Let's check it. Here we go, guys, right? So we have successfully submitted with C++ as well, right? Now let's move to the Java programming language quickly. And in the Java, first of all, let me define a mode, right? So we can say int mode is going to be nothing but 10, 2, 4, 6, 7, 8, 9, right? After that, we are going to say our map. So we can say map. It's going to be string string, and here it's going to be data type is integer. Let me write an integer, and here we can say map name is going to be nothing but dp is going to be new map, hash map, right? Fine. Now what we are doing, we are going to define one more function, public int sol, and you're going to take first of all idx, then total fuel, then we can say finish, then we can say in fuel, then we can say location, then we can say n, right? After that, we are going to say if our dp dot contains key, right? And key is going to be, we are going to define if it is contains key, so we are going to say dp dot get key. We have to return this, right? So what is key ever? So we can say key is going to be nothing but string key is going to be index plus colon, let me write colon plus key fuel, right? So this is going to make a unique key every time, right? Because index and column is going to be changed, right? And if it is same, so we are going to return whatever we have got already the value, right? After that, we are going to check if total fuel is greater than our given fuel, so we are going to return nothing but 0, right? But if our index is equal to finish, so we are going to see again, guys, we are doing again same mistake, finish, right? So return, not return, you have to increment your answer, right? We have got one path, so we have to define an answer as well. So int answer is going to be equal to 0. Fine. Once this is also done, we are going to say okay, traverse all the cities again for int I is equal to 0, I less than n, I less than n, I plus plus. We are going to say if our answer, not answer, if I is equal to idx, same city, so we don't want to do, so not return, continue this particular part. Let's move to the next city. And if it is not the same, if it's different cities, so let's move there as well, right? So we can say answer is going to be nothing but answer plus sol. We are going to call sol for I this total fee is going to increment by absolute value of, we have to use math dot absolute sol dot sol, we have to say locations I minus location of idx, right? Locations of idx. After that, what we are going to do, we are going to say okay, then finish is going to remain same, fuel is also going to remain same, location is also going to remain same, and then end, right? Once this is done, we are going to say fine. After that, we are going to say return this answer, right? And before that, we have to do two things. First thing, store in our dp dot put this key, you have to put answer, and second thing, we have to do a mode, right? So we have to say mode, and here we have to use a bracket, right, for mode, right? So let me do like this. Fine. Now let's call this function. We are going to say return sol. We are going to say index is going to be nothing but start. Then we are going to say total fuel is going to be nothing but fuel 0, right? And finish is going to be the same. Finish. Let me write finish. Then fuel. Then locations. Then we are going to say end, right? Let's run this. Going to see whether it's working fine or not. I'm doing a little quickly, guys, because we have already done this with two programming language, C++ and Python. And also feeling index is equal to finish, so return answer plus plus, it's fine, right? Cannot find a symbol finish. Why? I have done a mistake only this here only. Wow, what's a mistake? Now let's see. Okay, so like one more error which is nothing but right, it's fine because we don't have n, right? So we have to say locations dot size, not size, not length, right? In Java we are going to use a length, and we are going to again get an error because locations this, right? Let's see when we have any more error. Let's run this code first of all and check. We don't want to see any more error, right? It should pass all the test cases. You can see all the test cases pass. So let's try to submit this code, and I believe, guys, it will also get submitted, right? Because we are using a memorization and recursion. So you can see, guys, we have successfully submitted with Java as well, right? So now we are left with one more programming language, which is last, which is nothing but JavaScript. So we are going to do with JavaScript, and we are going to define first of all const mode, which is going to be nothing but 1, 3, 6, 9. Let me do 4, 6, 7, 8, 9, right? Fine. After that, what we're going to do, we're going to say define dp. So let dp is going to be new map. Fine. And then we are going to define nothing but n, right? So let n is nothing but going to be nothing but locations of fuels, right? Location of length, right? After that, we're going to say define one function which is nothing but const. The function name I'm going to give a sol, and the parameter is going to take nothing but index and fuel, like total fuel, right? Let me use arrow operator first of all. Fine. And here we are going to return something, but before that, first of all, check it. If first of all make a key, let key is going to be nothing but back, which is the symbols, right? This is symbol, right? And we are going to use dollar symbols, and here we are going to say index, again dollar symbol. Let me write a first of all comma, then dollar symbol, and here we can say fuel, right? total fuel. What we are going to do after that, we are going to say we are going to check it first of all. If key is equal to, if key in our dp, right? So dp dot has this key, so we are going to return dp dot get this key, right? We are going to return dp dot get this key. So this makes sense, right? So this makes sense. But if it is not the case, so what we are going to do, if it is not the case, if dp, if our key is not if key is not fuel, for that we have to check if t fuel is greater than our fuel. So we are going to return directly 0, right? If fuel is greater than 0 fuel, we are going to return 0. But if our, we can say t fuel, remove this t fuel, we are going to check the condition about that particular index, right? If index is equal to finish, so what we are going to do, we are going to say increment answer plus 1, right? So we can say int answer is going to be nothing but, not int, we are going to use a let variable here. JavaScript int answer is 0, so we are going to increment by 1. And also we are going to traverse on each city, right? So for let I is equal to 0, or we can say let I is equal to 0, I less than n, I plus plus. And here we're going to check if I is equal to this particular given index, so continue this part, right? Continue this part. But otherwise what you're going to do, you're going to say calculate answer is going to be nothing but answer is plus, you can say solve, this particular solve function, you are going to pass index this I, and total fuel is going to be nothing but, total fuel is going to be nothing but plus math dot abs, and you're going to say what you can say, you can say locations of I minus location of idx, right? And here we can say, after that we are going to say dp dot, you can say on this particular key, right? So how we can put this particular things, so for that you can say dp dot set, right? Set, and then you can say on this key you have to set this answer. After that you can say return our dp dot, not dot, we can directly return answer as well, right? And here guys we are going to call this function, so we are going to say call this function solve, and you can directly return solve, and here you can pass solve. After that what you are going to pass, you are going to pass nothing but 0, not 0, we can say yeah, start, right? And here we can to pass 0, right? So see guys, what we have done, right? We have passed start and 0 here, was the only thing which we haven't done here is nothing but we haven't used a modulus of it, right? We have to use a mode, right? So here we can do mode, we can do one mode here, even though, like, let's do here only. So what I'm going to do, I'm going to say mode, and here we can take a bracket, right? So let's check this, and this is my first time with the JavaScript, so let's check it. We may get an error, right? So let's see whether we have done any mistake or not. So we haven't done any mistake. Wow, let's try to submit this code. We have done a mistake in Python, C++, Java, but not in the JavaScript. That's amazing, right? Hopefully it should also get submitted, right? So we have successfully submitted with JavaScript as well. So guys, we have seen implementation part in for programming language, Python, C++, and Java. We have also seen the logic part. We have also seen the problem understanding part. So if you have any kind of doubt in these programming, parts, so you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet in the next video.